Okay, so in this series of lectures we're going to talk about record linkage, which is essentially trying to put together the same entity, whether it's an individual or a business or anything that we're interested in, and combining different sources of data. So it's a fairly long overview. Structure, I'm going to provide motivation, and then we're going to kind of give you some context about the structure of the way in which we're going to look at these things. I'm going to walk you through some of the pre-processing issues, and then do a deep dive into the rule-based and probabilistic approaches. So that'll kind of give you an overview of the nuts and bolts of record linkage. Now, if you take a look at the history of record linkage, I know that it's difficult to go back into the history books and look in Encyclopedia Britannica and say, when did record linkage first come about? Nowadays we tend to look at Google trend lines and so on. So you go back and take a look, as this slide does, to say, how often were people searching for record linkage back in the day? Or how often was record linkage, used in text back in the day? Because of course back in 1945 they couldn't Google things. And this slide is really interesting because what it shows is that, you know, in the 1960s and 1970s, record linkage, people were really initially starting to think about it. We'll be talking later on about the Linkage-Sumter approach. So in those days, there was some interest in how do you combine data sets for different sources. But if you take a look since 2005, the interest in record linkage has soared. And of course, the reason for that is there are many more sources of data, there are many more ways to combine information, and so the processes by which we automate the combination of information from different sources, the ways in which those have developed have escalated similarly. It used to be that it was okay just to do a merge using if these two elements are the same, then we're going to match. Nowadays it's much more complicated. So, you know, this is obviously a big data type of class, and what we want to emphasize is that there's enormous opportunity associated with combining data from different sources. When you combine data from different sources, you get new insights into the behavior of individuals and of people. So, for example, when I first started with the LEHD program, people were very much focused on just using survey data. The insight that came from administrative records, that is, the records that are generated from the administration of government programs, is that you have massive amounts of information, for example, the unemployment insurance wage records, where you've got information that's very wide. You've got information about name, social security number, and earnings for all individuals in all covered firms in all states in the United States. And you've got that over time. So you can do a lot with describing the employer-employee dynamics, the job dynamics in the economy that wasn't possible before. But of course, when you look at those job dynamics, you have no understanding about who is changing jobs. You don't know anything about the characteristics of the firms and so on. So what you want to do is you want to combine information from different sources. That means you've got to think about how to do those combinations. That's very much what this lecture is about, combining information from different sources. When I was talking about LEHD, you notice I was talking about over time. You can link the same data set at different periods of time, so you could link a wage record data set from Illinois in 2001, quarter 1 to quarter 2 to quarter 3 to quarter 4. So that enables you to trace the patterns or the pathways of an individual through the labor market over time. But of course then that requires that you know that you're looking at the same person. You can also link across entities. So for example, if you're looking at my pathways, you might be interested in the role of geography, access to transportation and so on. So you've got information about me as an individual, you've also got information about my geography, so I might want to link across geography or my firm and get more information about that. One of the things that obviously when you're dealing with administrative data or transaction data like credit card data or so on is with administrative records and transaction data, the data get updated with new transactions or new information sometimes on a daily or a weekly or a quarterly basis. So when you're trying to update files, you've got two options. One is simply to replace the file, another one is just to replace the duplicate entities in a file. Well, to figure out those duplicate entities, you have to know it's the same entity that you're looking at. So those are the opportunities to get much richer information out of your data by linking the information together. There's huge amount of value associated with this. So you can use the new linked data sets for resource allocation. And I'm going to talk through an example about this in a minute. When I'm able to link data from different programs, I can use the resulting linked data to say, how should resources be allocated for social services, to allocate more resources to lower income individuals, for example. Or I could use it to detect fraud because I can combine information. It's also going to help in cost reduction. If I'm worried about identity theft or about fraud detection and so on, I can use that information. So let me make all of those ideas very concrete and talk about work that was done in New Zealand. And the next slide kind of talks about that. This is from a presentation that Sir Bill English, who was former Prime Minister of New Zealand, gave in New York last year. New Zealand is like any other government entity. The main sources of expenditure are pension funds, New Zealand Super, health services and education services. So that big box is kind of showing the allocation of the budget. And back in about 2000, 2001, largely built on the LEHD program, New Zealand started to put together the building blocks for an integrated data infrastructure. And so if you go onto the Stats New Zealand website, you can find out more information about the IDI. But essentially over the past almost 20 years now, an integrated data infrastructure that combines administrative data from multiple programs has been built. And so a lot of this requires to have good linkage algorithms. So let me explain, kind of as a motivation for what we're going to go through in just a minute, what this means. So this is an example. The age of an individual is at the top line, aged 1 through 19. And you can see down the vertical column the different programs, the different administrative programs that this individual has touched. Children, youth, family services, abuse, care, foster care, education, youth justice, income support, and then at the bottom is the dollar cost to society of interacting with those programs. That of course is quite separate from any other costs, which one might want to monetize as well. But essentially if you look at that picture, you see the child being born, and then when you take a look at Children, Youth, Family Services, you see that child is showing up with reported cases, some of which showed up as positive with abuse by age 5. So you're already starting to get a picture of a child that is having a tough time as an infant and toddler. Then you see age 5, they go into the education system. By about age 8, those administrative records are starting to show spotty education attendance. And that drops out almost completely. There's quite a large hiatus between age 9 and 10. And then you start seeing showing up in children and youth family services and abuse findings, goes into foster care, goes into care over and over and over again. And then you can see by the time they hit 14, their education has dropped off, they're starting to show up with youth justice, and then by the time they're hitting about 15, 17, they are showing up as on income support. So you can use these data. Obviously that tells a story about what's happening to that individual, but you can also use these data to help identify risk, for the predictive analytics that can help allocate resources. So here's an example again from Sir Bill English, which takes a look at predicting whether or not a child in a particular cohort in New Zealand finishes their educational qualifications, the NCA2. And you can see that for one group of individuals, the group coloured in green, there's a relatively low chance of them not getting their qualifications. For the group in red, there's a very high chance of them not getting the qualifications. So the group in red, it would make sense to allocate resources to them, because if you don't get your educational qualifications, your future career trajectory, your future ability to be a productive member of society is substantially compromised. So, you know, you could think as for policy, reallocating resources away from the kids who really don't need them in order to graduate, if that's your target goal, and towards the group that are at risk of not graduating. And the next slide kind of gives you a sense of the dollar bottom line. As I said, there's also a social bottom line, but a dollar bottom line, the cost of providing services is about $72 billion, and that's your liability. And by using the data to better predict outcomes and providing interventions, you can reduce that liability by almost $14 billion. So this provides the motivation to some extent for policy, evidence-based policy. So that's a very, I think, powerful example of how data can be used. You can to inform policy decisions. You can also use it quite simply to make develop better information about key indicators, like how long people are in a job. Now, you can ask someone how long they've been in a job, and there's value in that. People can tell you. But it's very expensive to go out and get that information, and you get it for a subset. You can also use administrative records to figure out how long someone has been in a job simply by looking at how often they show up on a payroll with a given employer. So in some of the early work, I'm going to say that I did published 2006, what we were looking at was, we said, okay, let's take a look at job duration. Let's take a look at people who are unemployed in 1 year, 1985, third quarter, and then let's see how many are still employed by that same employer in subsequent years. Now, the follow-up on that, if I were to try and do that in a survey, would cost a lot of money, and frankly, the quality is not so high when you're asking people to remember this. But what you're able to do is to compare the differences in job duration in manufacturing and non-manufacturing, not by burdening people by asking them the question, but simply by looking at the data. Now, of course, that requires, if I'm going to look at job duration, I need to be sure that's the same person that I'm looking at. So that requires matching the records from one quarter, 1 year to the next. So what does this involve? And that's kind of the story that we're going to be following through today. So at the core, it's a very simple problem. I've got two data sets, data set A and data set B. I need to look at all the entities in the data set, and I need to make a judgment. Is it a match or is it a non-match? But there lies the problem. You know, if it were 30 individuals in one data set and 50 individuals in another, I could just go down 30, see if any one of those 30 matched the first row, second row, third row, fifth row, all the way down to 50. So I could do a set of pairwise comparisons. Anyone who stops and thinks about that for a minute, 30 times 50 gives me 1,500 different decisions that I have to make. If I blow up that to millions, it's just not doable manually. So what we've got to do is we've got to figure out automated ways of saying, are these the same person? There's some very, very good books out there. I've highlighted two of them in the next slide. The book by Peter Christen is excellent, and of course the book by Tom Herzog, Fritz Schuren, and Bill Winkler are highly technically insightful. So recommend that you take a look at these after you've gone through this very cursory review. So here's what we're going to do. We're going to walk through the pre-processing steps, and then we're going to go through different record linkage algorithms. Now I'm going to tell you, pre-processing is kind of the Cinderella of any kind of data work. It, as you see from this point, about 5% of the quality of a given match is going to be the algorithms, even though we're going to spend a lot of time talking about that. 20% is figuring out whether or not the matching is correct. 75% is the data cleaning. So we're going to spend some time talking about the data cleaning before we go on to talk about the matching algorithm.